Hi everyone. Today the topic is models for excess Gibbs energy. So here we see what are the different models which can be written for excess Gibbs energy. So for binary system, GE by x1 x2 RT is expressed as a power series in x1. So excess Gibbs energy, it's represented by GE. So here we consider the expression GE by x1 x2 RT. So GE by x1 x2 RT is equal to A plus B x1 plus C x1 square plus and so on. So this expression is written at constant temperature. So here for a binary system, x2 is equal to 1 minus x1, so which has species 1 and 2. So for this, one power series known as Redlich-Kester expansion is written as GE by x1 x2 RT is equal to B plus C into x1 minus x2 plus D into x1 minus x2 whole square plus and so on. So now we consider the equation ln gamma is equal to dou of NGE by RT by dou Ni at constant pressure, temperature and Nj. So when we apply B equal to C equal to D equal to and so on equal to 0, then G by RT becomes equal to 0. So when G by RT is equal to 0, then according to the previous expression, ln gamma 1 becomes 0 and ln gamma 2 also becomes 0. So in this, gamma 1 is equal to gamma 2 equal to 1 and the solution is ideal. So this represents the ideal solution. But if we consider if C equal to D equal to and so on equal to 0, then G by x1 x2 RT is equal to B. So B is a constant for given temperature. So for this, if you write the corresponding equations for ln gamma 1 and ln gamma 2, then the equations are ln gamma 1 is equal to B x2 square, ln gamma 2 equal to B x1 square. So simply if you write the expressions, then ln gamma 1 and ln gamma 2 can be get as B x2 square and B x1 square. So the infinite dilution values of the activity coefficients are given by ln gamma 1 power infinity is equal to ln gamma 2 power infinity is equal to B. So if D equal to 0, then the above expression becomes G by x1 x2 RT is equal to B plus C x1 minus x2. So which can be written as B plus C into 2x1 minus 1. So from this we can recover the module's equation by substituting B plus C is equal to A21 and B minus C equal to A12. So in this way we can write the Redlich-Kester expansion in different forms. So now we consider the next thing, that is the reciprocal expression, that is x1 x2 RT by GE as a linear function of x1. So if you take x1 x2 by GE by RT, which is equal to B prime plus C prime into x1 minus x2. So which is equal to B prime plus C prime into 2x1 minus 1. So x1 x2 by GE by RT is equal to B prime. So in place of 1 we substitute x1 plus x2 plus C prime into x1 minus x2. So here B prime plus C prime into x1 plus B prime minus C prime into x2. Now we consider B prime plus C prime is 1 by A21 prime and B prime minus C prime is 1 by A12 prime. Then the above expression can be written as x1 x2 by G by RT is equal to x1 by A21 prime plus x2 by A12 prime, which is equal to A12 prime x1 plus A21 prime x2 by A12 prime A21 prime. So finally when we combine these two, finally we can write the expression as G by x1 x2 RT is equal to A12 prime A21 prime by A12 prime x1 plus A21 prime x2. So the activity coefficients implied by this equation are ln gamma 1 is equal to, so if we take a12 prime outside, then we will be getting a12 prime into 1 plus a12 prime x1 by a21 prime x2 to the power of minus 2. Similarly, ln gamma 2 is a21 prime into 1 plus a21 prime x2 by a12 prime x1 to the power of minus 2. So these equations are known as Van Law equations. So based on these Van Law equations, we will get different problems. So when x1 becomes 0 for this equation, ln gamma 1 power infinity becomes equal to a12 prime. When x2 is equal to 0, then ln gamma 2 power infinity is equal to a21 prime. So we have seen the Redlich-Questor expansion, the Margulis equations and Van Laar equations. All these equations are special cases on equations for GE given by different ratios of polynomials. The next one is the Wilson equation. So Wilson equation contains two parameters for a binary system, that is a lambda 12 and lambda 21. So this is a capital lambda and so this capital lambda, so lambda 12 and lambda 21 for a binary system. So on this expression for this is written as GE by RT is equal to minus x1 ln x1 plus x2 lambda 12 minus x2 ln x2 plus x1 lambda 21. So from this ln gamma 1, the same thing, ln gamma 1 is dou of j and g by rt by dou x1, that we have to apply. Based on that, ln gamma 1 is equal to minus ln x1 plus x2 lambda 12 plus x2 into lambda 12 by x1 plus x2 lambda 12 minus lambda 21 by x2 plus x1 lambda 21. Similarly, ln gamma 2 is minus ln x2 plus x1 lambda 21 minus x1 into lambda 12 by x1 plus x2 lambda 12 minus lambda 21 by x2 plus x1 lambda 21. So when you write these expressions for infinite dilution, then ln gamma 1 power infinity is equal to minus ln lambda 12 plus 1 minus lambda 21. Similarly, ln gamma 2 power infinity is equal to minus ln lambda 21 plus 1 minus lambda 12. So here lambda 12 and lambda 21 both are always positive numbers. So the Wilson equation for multi-component system can be written as, so now we have written for binary system, then we are writing for multi-component system. So GE by RT is equal to minus sigma I xi ln sigma j xj lambda ij. Similarly, ln gamma is equal to 1 minus ln sigma j xj lambda ij minus lambda k xk lambda ki by sigma j xj lambda kc. So here lambda ij is equal to 1 for I equal to j. So in this, all indices in these equations refer to the same species and all summations are over all species. So here we represent the species I and j. So for each ij pair, there are two parameters because lambda ij is not equal to lambda ji. So now the temperature dependence of the parameters is given by lambda ij is equal to Vj by Vi exponential of minus Aij by Rt. So here I is not equal to J. Then only we can write the temperature dependence. So here Vj and Vi are molar volumes at temperature T of pure liquids I and J. And Aij is a constant independent of composition and temperature. So Wilson equation establishes an approximate temperature dependence for the given parameters. So this is the Wilson equation for multi-component system and Wilson equation temperature dependence is also given. So totally we have seen about Redlich-Kistler expansion. Already we have seen Margulies equation, Van Laer equations and Wilson equation. So these are the different models for excess Gibbs energy. So based on these different models, we will solve many problems based on these models. You will also get many problems in the examination also based on these problems. Based on these equations. So these are the different models for excess Gibbs energy which you have to remember, and you have to substitute the different values in those equations and solve for gamma 1 and gamma 2, the activity coefficients. So this is today's topic. So if you like my video, please subscribe my channel. Please like, share and comment my videos. Thank you so much.